Welcome to another episode of our CS Club. Today, we'll be learning about Java control statements. My name is Aaron Lin, and this is Obvious Java. If you want to code along with this video, do actually join our link over here as provided, and then search for 32C9 in our chat in order to bring up any relevant materials. So let's get started. So there are many reasons why we want to use control statements because most programs they simply don't run in a straight line. A lot of the times they need to make choices to go different ways. And if there are no choices in programs and the program were to run linearly, then either the program will end really quickly or it just keeps stopping. So that kind of makes the program quite useless. So there are many kinds of control statements. We have decision statements, we have loop statements, and then we have jump statements. So in the decision statements, we have if and switch. In the loop, we have for and while. And then for jump statements, we have break and continue. So if you want to have another word to remember these statements, then maybe you can use the words choosing, repeating, and skipping. Then maybe it can help you remember it better. So let's get started with the first one, the if statement. If statement is probably one of the very first ones that you come across. So it contains an if, a condition, an opening brace, and a closing brace. So in between these two braces, you'll want to do something. So you will do something over here. Do something. And that is pretty much it for a basic if statement. So let's take a look at a few examples and see whether we can understand it a bit better. This is my drawing board, and then I'll put my code over here. Okay, so we would try to start with perhaps an integer, int, and let's call it a wallet. Do note that you can call this anything you want. Really, you can seriously call this and put a random name or whatever. This is important to know that you can change the name of whatever you want this to be. But in the meantime, we just put wallet equals 20. So my wallet has now $20 because wallet equals 20. And then we will move on to the next one. We will write the if statement. If, so condition, opening, closing braces, you can type it like that. Then you go inside and just press enter. Then you should get something like a body. So what is the condition? A condition is basically something that you want it to evaluate to true or false. So let's say if I put something like wallet less than 20. So Java is complaining because it already knows the answer, but in practice, it shouldn't be able to just know the answer like that because programs are a little bit more complicated. So wallet is less than 20. Since my wallet is 20, this is not true. It is false. Therefore, it will not run. So let's try something. We'll print something. Wallet is more than 20. So if this is true, Java will go inside to the body here, as you can see with the yellow line, and then it will do whatever we tell it to do. If this is false, Java will nope, will go out, and then you carry on down the line to the next part of the program. So let's run this and make sure we have nothing. So as you can see, Java ran and then process finish with exit code 0. That means there are no problems with the program. But Java didn't go inside of this statement after it touched this and evaluated this, because this is false. Now, how do we make it true? So what is bigger than 20? So if we put something like 21, this will be true because 21 is indeed more than 20. This will be true. And let's see when we run it whether this is the case. And there we go. So we have printed whatever that we wrote here. We told Java to print out this statement, this sentence, wallet is more than 20. This is a string, not a sentence. So what happened is Java will go down and read this. Okay, wallet's 21. Then you go down and you go down. Then Java will evaluate this. Is this true? Yep, it's true. I will go inside. Then Java will go inside and do whatever we tell it to do. In this case, wallet is more than 20. We want it printed. Java prints it for us. Now let's move on to a little bit more, a few more statements. So we can actually do a few more just to prove the point. Like that. So I will change this to 40, 60, and 80. So 40, 60, 80. So what happens now is after Java runs the first one, evaluates, and whether it runs or not, it will move to the second statement. Then it will evaluate this and check whether it needs to go inside, and then a third one, and so on. So in this case, Java will only execute this statement on line 13 because it comes here. This is true. It goes inside and does what we want it to do. It gets out. But then you notice down the road, this is all false because this is less, 21 is less than 40. This is also false. This is not true. This is also not true. And then to prove the point, we will press play. And then we will see that only one statement is printed, which is still the old one of 20. Now, if we want this statement here to evaluate true, and then this to evaluate true, we will have to put something bigger than 60. So let's try 65. And then you notice this, and this will print. Like so. Let's take a look at the debugger and see whether our assumptions are correct. So we'll run the debugger like that. And then you notice that Java has instantly read the wallet. It's really quick. It read the wallet at 65. And then it goes down. So the blue line is where Java is right now. Then Java is thinking, is it true or false? Then Java is saying, yeah, this is true. Then you go inside, do whatever you want. In this case, we actually print it. Hang on. We actually print it like this. Oh, I'm not sure why this is not updating, but okay. And then you go inside and then you evaluate. Is this true? This is true. You go inside, then you get out. Evaluate this. This is true. Okay, I go inside. Then you do whatever you wanted to do, and then you get out. So this is false. You notice that you'll never touch line 25. Java will never go inside these statements. Then you just skip all the way down to the end. And that's how the program ends. Let's take a look at another example. So if I were to put something to, okay, I will have a wallet here like so. And then I will use something called a scanner. So this is basically something that asks a user to type what they want, but we learn about this in the near future. Like so. Scanner. So like this. Okay. So what happens is when I run a program, I will initialize my wallet, and then program will ask me, enter the amount of money you want for your wallet. Then this will prompt me to enter this an integer, and then I will travel to the bank, and then I will ask myself, is my wallet less than 20? If that is true, I need to draw more money. I will go into the bank. Then you ask me again, how much do you want to draw? After that, I will get out, and then I'll ask myself, if I have $80 to buy the game I want from the shop, then I will enter the shop. If I do not have 80 bucks, I'll just skip it and I'll just go home. So let's give the program a run and see what we get. So if I have $40 for starters, for 0, like so, then you will notice that I will not actually do an hang on. I will not actually do anything because I have more than $20, so I don't have to go to the bank. But I don't have $80, so neither of these actually runs. So let's try something that has less than $20, like this. Maybe we try something like 15. Oops, no emojis here. So when I have $15, Java will go down and say, oh yeah, I have less than $15. I will go inside. And then Java will run this line here. Then that's why you see this print over here. And then I am prompted to type in something. So the moment I type in something, Java will say, oh, I'm done with this if statement. Let's get out. And then Java will ask, do I have $80 in the wallet? Yep. I will go in. I can afford the game. I'll buy the game. Then I'll just get out. So if I withdraw $100, I would have way more than $80. So can afford the game. Can afford the game. So that's another example for you with if statement. Now let's move on to a different version of the if statement. Let's try something else like, oh, before we do that, let's move on to dependency first. So it is important to know that if you have multiple if statements like we did earlier, each if statement is independent of each other. So no matter what happens here, Java will still evaluate it. And if it's true, you'll run. Then no matter what happens here, Java will still evaluate it. And then you move on, you still evaluate it. If it's true, you run, and so on. So all of these are independent of each other. Now let's move on to another type of if statement, and that is else if. Else if is something that you append to an if condition. So it's pretty much the same thing. Else if condition, opening braces, closing braces, do something else. So you notice I said else over here. That is because this is actually two statements over here, if and else if. This one, if it's true, will run, then Java will do whatever it needs to do here, and then it will get out. If the if statement is false, then Java will move on to the next one and then evaluate it. If it's true, it will run it, and if it's not, it will get out. So you can see here that this is basically a second chance to run something, if you want to put it this way. If this one doesn't run, then I'll try again, and so on. So let's see how we can put this into use. So I'm going to clear my whiteboard like here. Actually, it's more like a blackboard, but okay. Then I will clear it like that. Now, We put it in a different scenario. Let's say I am solely going to a bank and I want to decide how much money I want to withdraw. If your wallet's really chock full of cash, you probably don't want to draw too much money because that kind of it's not really safe, to put it one way, to carry too much cash, right? So we will try something like this. So what did I do here? I have an if statement here with a condition, and then I have multiple else if statements. So how do we read this? If the wallet is less than or equals to 20, let's say 15 or something, I will go inside the bank. Let's say this is the bank, and then I will withdraw $80. Then I'll print out that I drew $80 to make sure I confirm it, and then I will get out. If I have less than $40, that means this is false and this is true. If I have something between 21 and $40, let's say $30, then this will be false because $30 in my wallet means that it is bigger than 20. So this is false. So I will go to the next one and ask, is this true? Then yes, it is true. My wallet has $30, less than 40 or equals to. So I will run this. Wallet plus equals 60. I withdraw $60 and I get out. I will be on my merry way. So if you notice, we cannot actually run multiple statements here like if statements. So let's say if these are all ifs, we can actually run all of them potentially. But because they're linked like this, the if and the else if, you can only run it. You can only run one thing, and then once you run it, you get out. So that is one of the ways to visualize this. So let's try something. We'll start with $21. So if I have $21 like so to 1, then I will go to the bank. Is this true? Nah, this is not true because 21 is more than it's not true. It's not less than or equals to 20. I'll move on to the next one. Then this is true because 21 in my wallet is less than or equals to 40. I'll withdraw $60 and then that's what the program will tell me. Withdrew $60. So let's try something different. Let's try 90. 90. So what happens in 90? It is false, 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 true. Then I don't need to withdraw. No need to withdraw, like so. So let's see how it works when we debug it. Oops, I need to select this. Debug. So 90. And then I will move on. So Java will ask, is this true? Java will say false. Actually, we already know the answers because Java spoils it for us. False, 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 true, like so. So Java will check, nope, nope, nope. Yep, okay, I'm going to go inside because this is true. Then you say no need to withdraw. Then you get out as such. So remember, only one of these options get to run at any one time. You cannot run many of them. If you want to run all of them or give them a chance to, you want to have a chance to run all of them, then you need to convert these and this and this to if statements. And that is else if. So let's move on to the dependency. Okay. So dependence. If, else if, else if, else if. So if you notice, there can be only one if in a statement, like so. If you put another if over here, then it will not be part of this set and you not work together. It'll just be something else entirely. So let's say an if runs. If this is false, then else if is also false. But this is true, then everything else down the line will not run. They're all skip. So this is one very important thing to know as well. Now, the final part of the if statement, we have an else. Opening, closing brace. So else is basically, I mean, you have heard of people saying, do this or else, something like that. So if nothing here wants to run, everything is false, then this guy here will always run. If you notice, there is no condition in my else statement over here. There's a condition for my if, else if there's also a condition, but there's nothing for my else. That means when this doesn't run, these two guys here doesn't run, or these 100 guys above doesn't run, this guy will always run. What does that mean? You will always have something run no matter what. So let's take a look at how we can make use of this. Okay, so let's clear my whiteboard. Stop my debugger because it's complaining already. Then I will put in another scenario. This time we're going back to the game shop. Everyone likes games, right? Here we go, game shop. So same thing happens. I'm going to initialize my wallet here. And then it will ask me, how much money do you want, or how much do you want to start with? Then you prompt me. After that, I'll go on my way to the game shop. Then I will ask myself, if my wallet has more than $100, then I will spend $80 to buy the latest Battlefield game. If my wallet, if this fails, I don't really have more than $100, but I still have more than $60. I'm still quite rich. Then I will buy the latest Zelda game for $37. But if I don't have more than $60, but I still have more than $40, I will buy some game credits, maybe like a consolation prize or something. But if I barely have at $40 or something, I need the money to eat, then I don't buy anything. I will cry on my way home. So when I run this, it is guaranteed that either one of these four will run. So let's try and see how it works. So let's verify that our if else if statement is working. We will start with $50 over here, 50, like so. And then you'll notice that I will just buy some credits because I don't have enough for the Battlefield game or the Zelda game. Press play. Oops, I shouldn't be doing that. I should be typing enter. Bought some game credits for $20 because this fails, this fails, this fails. Now, let's make all of them fail. I want this to fail. False, false, false. So to do that, I'll have $30. Like so, $30. And then I'll press enter. I will cry on my way home. Let's see how this works. So I'll try $30. Oops, I gotta debug it. 30. And I have to put a stopping point as well. Yep. 30, like so. And then Java will run all the way down to the game shop and it will ask itself, is this true? No, it's false. No, it's false. No, it's false. So I will definitely run this no matter what. Then cry on the way home. Like so. And that is how you use else statements. Now let's look at the dependency for each of them. So if I have something, if, else if, else if, keep in mind I can have many else if in between, maybe 10, 20, 30 if you really want it, but in most cases that wouldn't be necessary. So let's say all of them fails. They render false, 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 false. Then else cannot be false. Remember that else does not have a condition. So it will always run, always, without fail. One and only one statement is guaranteed to run. If nothing is run, the else will always run. Okay, let's move on to the next decision statement. And this is switch. Switch is a little bit more fun. So let's see how we can make use of it. So to make a switch, we will type in switch input opening brace and do not forget closing brace. So when you open your brace and you close your brace, this is your body over here for the statement. Note that this is not a condition. This is an input. It's different. So when we have a switch, we want to have an input. Let's say my input is 1. I will choose case 1. So make sure you know your indentation. So case 2. So if my input here is 1, then I will do something in case 1. If my input here is 2, I will do something in case 2, and so on. You can use alphabets, you can use A, you can use NSC, you can use whatever, or you can use a lot of things. So after you put your cases, it can be 2 cases, 5 cases, 10 cases. You want to put something called a default. So before we go to default, we need to make sure that every time we do something here, the last line of the case, we have to put break. Why do we need to break? Because if we don't break, we go to case 1, we do something, then we go to case 2, we do something, we do everything in the switch. Then it's not even a switch anymore, it's like a box of trash. So this is why you need to put break so that Java will come in. Oh, it's 1. Java will go into case 1, do something, break. Okay, time to get out, you break, and you go out. So what is a default? A default is basically something that happens when none of your cases actually manage to be the same as the input. So if I have case 1, 2, 3, 4, 5, I have 7. That is not something that we accounted for, so it will be default. It catches everything else, basically. So it is almost like an else statement in an if you want to think of it this way. So let's write something to test out our switch. Gonna clear my whiteboard. Clear. Bye bye. And then I will put my switch. So I'll just paste it in so that you don't have to see me type all day. So this is a scanner, and then basically this is something that scans, asks me what I want. We will learn about all this more in the future. So it will ask me what school am I thinking of. I'll put something that I think of. So you notice that the switch has the school as the input. So whatever I type here, if I type here ABC, my school is ABC, and my switch is ABC in the input. So you notice that there are many cases here. We have the North Seattle College. So when we go to case NSC, the system will tell us this is a 2-year college. SSC, 2-year college, and so on. WSU, this is a 4-year college. UW, 4-year college, and so on. Remember that we do indentations here. Do not forget about them. And then we have to break out of the case once we are done with them. Or else we'll be running this, and our program is trash. So let's try something. Oh, before that, why is Java complaining? Because we have too many braces. So if you get stuck and maybe you have one too many braces, or you have maybe too few braces, you can start. If you're using IntelliJ, you can start with the first brace by clicking on it. You can see it turns yellow. Then you just scroll all the way down. So you notice that my yellow brace is here, the closing one. So this is redundant. Gone. Okay, back to what we were talking about. Stop and run again. Make sure we get everything reset. What school are you thinking of? When I type in NSC, we can expect the system to print this is a 2-year college. So this is a 2-year college. So we'll try again. If we want to print UW, then it will say that is a 4-year college. So remember our default case, everything else, we put what's that. So this guy here, this case, will catch everything that is not accounted in these 6 cases over here. So let's try putting trash inside, see what happens. Let's say I make something funny, whatever, random trash. Then you will say, what's that? Because you will go down and you check the table and then it says, oh, it's not here, so I'll do the default. What's that? So why should you use switch instead of many if statements? You can ask, I can put like 6 if statements, right? Isn't it the same thing? Then in practice, it may be right. But let's see why the switch is better compared to like 6 if statements. Let's take the last one, UWB. I will do a debugger and then let's see what happens. Oops, I need this to stop like that. Then, okay, what school are you thinking of? UWB. So that is the last option over here, the 6th option. So if these are if statements, we can expect Java to running evaluate this, true or false, true or false, true or false, true or false, true or, and so on. It takes quite some time in terms of processing. But look what happens when I were to do it with a switch. Pick the last option, UWB. And then enter. So Java will be at the door of the switch. It will start over here. Then you might think you will go all the way here one by one like this, but it actually goes to UWB instantly. All these 5 cases, they're all skipped. They are not being used and wasted. Processing is not being used and wasted for these 5 cases. Because switch puts whatever you put in your cases on the table, it doesn't have to evaluate all of this. You just skip everything. So switch is actually much more efficient in that manner. And this would be the best way to use switch. You notice that Java is still complaining about something. It's nagging at me. You notice it's giving an underline like this, like this. So the second one like this, like this. So it's complaining. It's complaining to me that I'm not using the switch efficiently. So how can we use it even better? So you notice that these 3 cases are the same. These 3 cases are the same. So what can we do? We can combine them. So let's try to combine them, see what we can do. So I'll put SSC, comma, SCC like that. So it's complaining because they're duplicates. So I will get rid of it like so. I'll put UW, Then I will put UWB. Thing again because duplicates gone like so. And you notice that no matter what I try, oops, let's see if I can zoom it nicely. No matter what I try, it will always give me the same correct answer. So what am I thinking of? NSC? NSC? Okay, that's a 2-year college. When I'm thinking of WSU, oops, WSU, 4-year college. So UWB, let's try. UWB, 4-year college. SEC. SEC is a 2-year college. So that is how you can use switch and make it more efficient. Of course, you can put more optimizations here like that, but you should not be using things that you do not know yet. So practice using the switch in this manner first. Then when you're more comfortable with it, you can explore something else. So let's take a look at something more interesting. Let's look at looping statements. The loop. So, what are loop statements? Loop statements are basically statements that let you repeat things over and over. So, let's look at a for statement. You probably maybe already been asked to do a for statement. So let's explore it in greater detail. So a for statement can be really scary at first glance, but it's actually really simple. You put in a for, you put in the parentheses, and then there are three things inside: the starting number, the ending number, actually not really the ending number, but we talk about it in a second, and then the counter. So when we start something, when we count from zero, we will start from zero, then we will count up 1, 2, 3, 4, 5 until the number we want to finish at. So when we say we start from zero, this is where we begin. We start from zero. And this loop will increase by one every time it's run. So 0 become 1, become 2, become 3. So you notice that IDX is always less than 5, especially at the start when it's 0, but it becomes 1, this is still true. Then the loop will begin again. 2, it's still true. 3, it's still true. 4, it's still true. But when it becomes 5, this is no longer true. This is false. And the for loop will stop repeating. So this is basically the counter. So IDX plus plus means IDX plus 1. So we'll put our braces, closing and opening, and as usual inside those braces, we'll do something. Today, we won't just do something, we'll blink a fancy light. So you notice that I spawned one light over here. So when Java runs this, it will make my light blink. So of course, this is not really Java. This is just a simulation of what's happening in the background very visually. So let's run it once and see what happens. So Java will come down from whatever it's doing, and then you go to the for statement like so. Then it will run what's inside. You blink once, then you go back up. So now you notice that your index is now 1 because it increased by 1 every time we run the loop. Then you blink the light again. Java go back up. 2. You blink the light again. 3. And blink the light again. 4. You blink the light again. But you notice that the moment Java goes up again, IDX will become 5. And when IDX is 5, this is no longer true because 5 is not less than 5, correct? So when the moment Java goes up and you say, oh, if I increase this to 5, this is no longer true. So I cannot repeat this loop anymore. It's time for me to get out. So that is what Java does, and that's how a for loop works. So let's take a look at an example. I'm going to clear my board. Like this. Close, clear, like that. And I'll paste in something so you don't have to watch me. Okay, so this is something that makes a noise. So just ignore this. What we want to focus is on the for loop. So what happens when we run this? Every time it runs, it will beep once. And then you'll wait a second, and then you say ping in the display over here. So let's run it once and see what happens. But before that, Java is complaining, hey, what's this? So do we have too many braces? Let's go up to the last one, the very first one over here, and see where we need them. So this turns yellow. That means this is the last guy we need. We move this guy here, and we will just get rid of this. No more complaining from Java. Okay, let's run this. So as you can see, it actually pings a few times. Unfortunately, I couldn't get the sound to go through over here, but I think you can see from here that it's actually pinging. So you run, ping, 1, 2, 3, 4. Then it will stop. So 0. So oops, 0. When it's 0, 1, 2, 3, 4. So let's take a look at with the debugger and see how it actually works. So the moment I start it, Java will go all the way down to my for loop, and then we'll run it once. So you notice that I is equals to 0. I'll do whatever I want over here. I'll ping, then it becomes 1. Then you go again, 2. Then you go again, 3. Go again, 4. Then you go again. So when it goes back up, it should be 5, but 5 cannot exist because I cannot be more than 5. More than 4. So the moment Java comes over here, you just exit. You go up, and then it would not run again. You just exit like so. Out you go, like this. So it's important to know that it starts from 0, then it runs 1, 2, 3, 4, but not 5. If you want to include 5, then you have to put an equals over here, like so. So I is less than or equals to 5. And in this case, you will notice that we'll run it 6 times, like so. 1, 2, 3, 4, 5, 6. And that is how you get it to reach 5. So remember to put your equal sign over here if you want it to reach 5. Otherwise, you just stop at 4. Pretty simple, right? Not so hard. So let's look at more ways to do for statements and a bit more of an explanation. So you notice that when we say I++ earlier, we can actually do something different. We can use idx plus equals 2. That means for every iteration, we increase idx by 2. So when we start at 1 like this, the next one we will increase it by 2, it becomes 3, it will become 5, but it will never become 7 because the limit over here says idx cannot be more than 6. So will not be 7. This loop runs only 3 times. So let's look at another example. So this one has 4 times. So you notice that we are going into the negatives already. So we will start at 3. You notice this is negative equals 3. So we are actually going downwards 3 times every time the loop is iterated. So this can go both ways. You can go positive or negative. Use your imagination. So we start at 3, like so. You'll remove 3 with each iteration. It becomes 0. We'll iterate again. Negative 3. We'll reiterate again. Negative 6. Actually, there should be an equal here, but there's a typo. There should be an equal here. So there's also one more way to do it. You can use something like this. You can use a double. Actually, don't do that. Don't go crazy. No. So let's look at something else. We will use a while statement. So a while statement is pretty similar to a for statement. It's actually repeating except for a couple of differences. So you know that for statements are something like this as we have discussed. So to make a while statement, we basically change it like this. We remove this and then put it outside, so the starting amount, and then we will remove the counter like so. This is a while loop. So let's take a little bit of a look at the example and see what it does. So I'm going to just remove my stuff over here. Poof. I also don't want these. Not necessary. So just ignore this. Like this. So a while loop. Boop. You can see it's really simple. It's almost like an if statement in terms of the condition. So what this means is when Java starts the program, IDX will become 0. You move down and you see, well, IDX is less than 5. So right now IDX is 0. This is true. Java will happily run what's inside. So what's inside? Inside says I want to increase my IDX by 1. So this guy here becomes 1 and so on. As we can see here, we run it and then you can see we have it 5 times. Let's take a look and see how it actually works. So we run a debugger again, and then we will start. Java has already ran downwards and told us IDX is 0. Java says, okay, I know IDX is 0. Then you go to the while. So Java will ask, as IDX now is 0, and then my limit is 5. So IDX is smaller than 5. This is true. Java will run whatever we want, and then inside says IDX plus 1. And then we'll keep repeating it because IDX is still less than 5. It will increase. It's now 2, but still less than 5. It's 3 now. Then it's now 4. But the moment you run it one more time, it becomes 5. So what happens when Java goes back to line 15 here and evaluate? It will evaluate to a false. So you notice that you say false over here. So what happens? Java will say, I am done. Java will get out and be on its merry way. And that is how you use while loop. One danger of while loop that new students may encounter is they forgot to actually do an increment or change something in the while loop. So IDX will start with 0, then it evaluates to true, but we do nothing to IDX. We didn't increase it in line 16. Then Java will run it again and again and again. You run it non-stop. So your program basically does nothing. So let's see what happens. I hope I don't crash. So you keep running, running, running. It might not look like it, but it's running non-stop. Let's stop it now before it goes crazy. You see, I'll click it here, and you will see that I am on line 100,000 and 116,500 lines. So in just a couple of seconds, we already run it 100,000 times. So that is something you want to avoid because I don't see how that's going to work out. So make sure that when you are running a while loop, you do not create an infinite loop because that will not actually get anything done. It will not come out very nice. So make sure to increase something so that your while loop will eventually stop and doesn't run forever. Okay, we have a couple more things to look at, but these are pretty simple. Let's take a look at a couple more. So these are jump statements. So jump statements are pretty simple. You got a break. How to write a break statement? Break. How to write a continue statement? Continue. Okay, so let's take a look at these two, break and continue, and see how they work. I'm gonna clear in this and take a sip of water because I'm feeling a bit parched. Okay, so I'm gonna paste something again so that you don't watch me type like a lot. Like so. Oh no, we got too many braces again. Go to the first one, click on it, it turns yellow. Then this is our last brace, and then we clean it up like that. So I'll put in my exception for both the function and the main. We will talk about this in an episode in the future. So what happened here? So I have two strings. I have a red string and I have a green string. These are formats for the background of the string. These will turn the background of the string red. This will clear it up. This will turn it green. This will clear it up. It's important to clear it up so that whatever you print next is not tainted with the same color. Maybe you want it to be different. In most cases, you don't want it to continue having the same color. So we have a for loop. So you notice this is, we are starting to get a little bit complicated here. We are putting a for loop and an if statement inside. So what happens? We start at 0 and then we will ask, we'll go inside and then we ask, is this true? I mod 2 is equal to 0? Yes, because the remainder when you divide the 0 by 2 is 0. Practically, this is just evaluating for an even number. So even number true, odd number false, because when you divide an odd number by 2, the remainder is not 0. So our print, so let's actually run it once. Be sure I don't talk too much. So green, red, green, red, green, red, green, red, green, red. How do I print two different colors when I run the same for loop every time? Well, this is how it happens because on the 0th iteration of the for loop, this is true. And then I'll print a green string for the 0th iteration as such. Then you see continue. Continue is a new word that we're talking about. Continue basically says that in this loop, I will end this loop, this iteration of the loop. So I'm not ending the loop, the whole entire for loop. I am just saying for this current iteration, iteration 0, I am done for this iteration only. So the moment this is 0, this is true, we get a green string, then Java will get out because it's a continue, then these will not evaluate. You will not print. Sorry, you will not see the red string, and you will not see everything over here. Then you go up again. You go to the first iteration. So the first iteration would be false in this if statement. So this green string will not run, but the red string will run, and then it will repeat. So when this iteration is 2, this is true. We'll print the green string as we can see over here. Oops, let me enlarge it. A green string. You print this, and then you continue. It means for this second iteration, I'm done. Get out. Oh, get out. So this will not be evaluated, and so on. And that is how you use continue. Just a reminder that this is one of the forbidden keywords in many computer science classes because it is so convenient. It is so useful. You want to use it all the time. But because of that, it encourages bad habits in programming. So make sure to check with your professor whether you can use them. So let's move on to the next one. We have break, as we have discussed over here. So break is kind of similar to continue. Let's see what we have. Mm, Okay, it's almost the same as what we are putting here. So like this. Okay, so this is pretty much the same loop as earlier. This portion is exactly, oh, here we go. Another problem with the braces. I click here, no yellow braces. That means we are missing one brace, like so. Okay, back to where we were. This is exactly the same as the previous one, but I have this extra portion over here that says break. So let's run it normally first. I'll put my secret code. Not so secret after I put it over here, so everyone sees it. So the reason there's a space because I pressed enter. So pretty much does the same thing, but the moment I put my secret code, it goes to -1, as you can see, like this. Oh, that's it. Oh no, what happened? We just cut short our for loop. So let's run it again. Um, Explain it again. So 0, this is true. It will run this green string over here, as we see. And then you get out for this iteration of the loop. You go to 1. This is false. Then you not go inside, you just go down. It will print the red string over here as such. Then it will go down and you ask, is my secret code 1? Yes, of course, because that is what I typed here. See? Then Java will say, okay, I'm going to go inside and I will print out terminating as such. Then I will break. The whole thing stops. So what is break? Break means I stop the entire for loop and I just get out completely. Continue stops the current iteration of the for loop, but break gets out completely. It no longer runs any more iterations of the for loop. It's completely done. And that is the difference between continue and break. Again, I want to reiterate that these two keywords are pretty much forbidden in many computer science classes because they make things too easy and they encourage lazy habits. So make sure you use them only if your professor allows it. Okay, so today you have learned quite a few things. You have learned decision statements, if switch. You have learned loop statements, for a while, jump statements, break, continue. These will form the bulk of your programming journey. Of course, there are more things that we can explain, but we have to wait for a better time down the road as they can be a little bit more complicated. We also have a for each statement and we have a do while, but we will do it another time in another episode. So, again, a last reminder, it's banned in some classes, so do take note. And that is it for today. My name is Aaron, and thank you for watching Obvious Java.